So okay, let's continue this unit. We reach up to ball valves. We finish ball valves. Butterfly valves are another type of the valves that what we have is we have, again, it's something like a gate, but it doesn't go up and down. It just turns right or left, and once it turns, it can open the flow. It can open the valve, and it can let the flow to go inside the pipe, and once it's closed, it will be totally closed and it will block the flow. So there are another type of quarter turn valve. So it means when they turn, they open or close like a plug valve, like a ball valve, and they are usually used for blocking the flow, not really for throttling the flow. Okay, they are usually used for blocking the flow. All right, they are usually used to block the flow at most of the time low pressure service. Okay, these valves are for blocking at low pressure condition. So they have a poor throttling characteristic. Throttling means, again, adjusting to flow. Okay, so they have a poor throttling characteristics. Okay, that's why they are rarely used for throttling or adjusting. So there are many used for blocking, open and close. Okay, control valve, as I said, control valve is a valve that is usually used to control the flow rate. Okay, the control valves is one of those types of valves. Let's say it can be is one of the type of the valve. Let's say it can be a gate valve. Okay, it can be, I don't know, a plug valve, glove valve. It can be any type of the valve plus another piece of equipment that is connected on the valve, on the top of the valve. Another piece of equipment at the top of the valve to, okay, just need to check something here. Okay, it's being recorded. Yeah, so is one of those type of the valve that you already saw, like a glove valve, plus another piece of equipment that is used to move this steam, this glove, this gate, whatever it is, up and down. And in that case, it can adjust the flow or even open or close the flow. How it works, it can use a pneumatic force. Let's say we can use a pressurized air in this line, and then we can here have a special design. We can have a diaphragm here, we can have a disc here that is connected to this rod here. So once we want to close this valve, what we will do, we send pressurized air to this line. The pressurized air will pressurize. We'll put a force on this disc or diaphragm here, and then it push this stem down so we can close this valve. If we want to open it, we will cut this pressurized air line so this disc can go up. So here we usually have a spring that move this rod up, so the valve will be open. So it will be working in this way. So now this is kind of open condition, and when we press it, when we send the pressurized air here, we can push this down and close the valve. Okay, so this is how it works, and we can use it to control the flow, start or throttle the flow, either remotely or locally. We can do it. It's something that works. We can do it remotely or locally on the site. And usually they have some other sensors they comes with other sensors that can measure the level of the liquid. They can measure the pressure, temperature, and some other other operating parameters. This part here, that is, we call it actuator. This part can work by using pneumatic force. Pneumatic means pressurized air. It can work by some electrical motor. It can work with hydraulic force or manual. Hydraulic is we use oil, pressurized oil, to move this rod up and down. So each of them is really depends to the service that we have, depends to the condition and some other parameters. Check valve, we already talked about it, is a valve that is used to block the flow. Okay, is a valve that let the flow only in one direction, and it has a gate. It has a part here that this part either can be moved by pneumatical force or by gravity. It's a metal part. It has a weight. When there is no flow from this direction, there is a flow from this direction. This valve goes down based on its gravity, and it will stay there. And it will block the flow from the right to the left. So it are used to keep the flow only in one direction. Okay, they are used only to keep the flow in one direction. That one example that, as I mentioned, is in pipeline, in the pump pipeline for discharging the liquid. Relief valve, we already again talked about it, is a valve that is called relief valve or pressure valve, pressure safety valve, or pressure safety valve, and also pressure safety valve, relief valve. So they are the valve that connected to a vessel, pressurized vessel. It has a rod here and a spring. So when the pressure in the vessel goes up more than the allowed value, so this gate inside the valve, this gate here, it will be open. It will be open and it will let the pressure to be discharged from the vessel or even the pipeline. And in this case, we can avoid any kind of problem like a rupture of the pipeline or explosion in the vessel. Okay, so that's about the relief valve. Okay, once the pressure is relieved, the valve will be closed automatically. Okay, so it's really for emergency case that the pressure is going up more than a certain value. So once that happens, this valve comes to the operation. Once the pressure is relieved and the pressure will decrease in the pipeline or in the vessel, then it will be closed automatically and the operation will return to its normal condition. Okay, safety valve also kind of pressure, they are the same. Pressure relief valve or safety valve or relief valve, they are also similar to each other, but safety valve they are a little bit different. And the thing is that the safety valves are really designed for a very immediate action. Okay, and the range of operation, the range of pressure that the safety valve comes to the action is much narrower than the pressure relief valve or relief valve. So, like, it's really used when we need a very immediate action to depressurize the vessel and make the pressure, to its normal operating pressure. And the good thing with this valve, they have also external lifting lever that can be used to test the valve to make sure the valve is operating. So most of the safety valve, they have an external lifting lever that can be used to test the valve to make sure that the valve is operating correctly. That's about our safety valve. Okay, rupture disc device. There are also another type of device that are used, just look at this figure here. So they are used for devices like this, okay? It's a disc. It's a very it's not very thick, it's a very thin disc that this is a normal condition. This is when it is burst out. So they will be installed in this way in the pipeline. As you can see in the pipeline, they will be installed this way, and they have always a piece of metal with their identification. Okay, it's written here what's the material of construction, what's the operating pressure that they can tolerate, and so on. So they are used to block the flow all the time. They are used to block the flow, except if the pressure in the vessel or in the pipeline goes to very, very big pressure, so they will rupture and they will let the flow to be released. So they are usually used in the vessels or the pipeline that we want to block the flow, except in very, very large pressure, so they will rupture and they will let the flow go through the pipe. So that's about the rupture disc. We have also another type of the safety valve or relief valve that we have is temperature and pressure relief valve. Temperature and pressure relief valve, they look like what you see in this figure. They have a spring here in this part, and they have also a metal part here. This metal part is very important. That this metal part is in touch with the fluid inside the vessel or the pipeline. Most of the time the liquid. Okay, so once the pressure in that vessel or pipeline goes up more than a certain allowed pressure, this spring comes to the action and it will relieve the pressure. And also, if the temperature goes up in that vessel, goes up more than the allowable temperature, so this metal can extend or expand, and expanding this metal, which is because of its thermal properties, it can also lead to this disc that is located here to be open, and it can relieve the pressure. So it's a relief valve that is used in really emergency condition, that then when the temperature and pressure they goes up in a vessel. Let's say in our houses that we have a heating system that provides us heated water, hot water for bathroom or for kitchen. So we have such a container in the utility room of the houses. We have such a container that what happen usually, there is a hot water will be stored here, and then it will be pumped to different sections of the house. We have such a valve, pressure and temperature relief valve, connected to those hot water container. So in case if there is some issues that the pressure here goes up, temperature of water goes up more than the allowable safety value, so this valve come to the action and it will discharge the hot water. Now I'm going to talk a little bit more about different part of the valves. So the valves, they have different parts. So most of these parts, they are similar, they are the same in different type of the valves. For now, as an example, I choose a gate valve and I'm going to show you different part of this valve. So the main part of each valves is usually this one: the valve body, port, bonnet. We have the valves, usually they have two parts. One is this part here that is in contact with the flow, and we have another part which is the actuator, which is usually that are not in contact with the fluid. They are not in contact with the fluid, and they are kind of sealed, and they separate, and are usually separated with some good sealing here in this part that separate the flow, and that they don't let the fluid to goes from this part to leak to outside. So we have bonnet, actuator, which is this part, stem, which is this rod here, packing. Yeah, this is the packing section, which is for sealing mainly. Packing gland, this part, and a stuffing box, okay, a stuffing box is also somewhere located here. Now we don't see it in this valve, but most of the valves they have it. Disc or gate, this part, and seat. Seat, where is this part that the gate will sit on it and it will close or open the valve. So valve body, that's the main part of the valve body that as shown in this figure. Then we have port, which is inlet port and outlet port. Those are the way where the liquid or the gas comes and leaves the valve. We have bonnet, which is this part that connects the actuator to the main body of the valve. Actuator is this part in general, but we call this part, which is the handle, as an actuator. If we turn this handle, we can open or close the valve. A stem is this part, okay? A stem is this part, this metal rod that it rotates, or it, it will be, it can rotate or it goes up and down, and that way it will close the valve. In the case of gate valve, it goes up and down. In another type of the valve, like ball valves or plug valve, it will be only rotating. It doesn't go up and down. Packing is this part, this packing section that will seal the valve and doesn't let the fluid to goes from this part, the main body, to actuator. Packing glands is also a part that will be tightened to seal the valve perfectly. Then we have a stuffing box. Again, those are all packing glands. Stuffing boxes are all located almost in the same area and are used to seal the valve. That's the disc or the gate. Okay, both names are used. And seat, where the gate or seat is located. Okay. Remote or automatic control valve. Okay, so as I said, for control valves, they have usually two parts. One, main body of the valve, that let's say we have a gate, that gate will be open. We have another part here, which is actuator. Okay, either it will be turning this rod, or it will goes up and down. So this actuator can be adjusted, can be moved either manually, okay, either by pneumatical force, hydraulic force, or electrical motor, okay, and they can be this actuator, it can be manual, it can be acting with pneumatical force, hydraulic force, or electrical motor, and they can be operated remotely far from the valve, because we just need to connect electrical wire or a line of pressurized air for pneumatical, or a line of oil, pressurized oil, to move this part. So it doesn't need to be, we don't need to be there. So all this can be done remotely somewhere far from the valve. So this is one example of pneumatical valve in one process. Then, okay, there are some main parts for the pneumatical valve. I'm gonna talk a little bit. So how it works. So this is the stem of the valve. So we can have a pressurized air line like this line. So when we want to close this valve, we open this line. The pressurized air goes to this part, and it move the valve, move the stem down and close or open the valve. So this is how we can adjust it. Or like based on putting pressurized air here or discharging, so we can move this part, this stem up and down, that this can be connected to the gate and close or open the valve. So we have an air line, so pneumatic line, that contain compressed air is coming from another unit, that this pressurized air will provide the force that we need to move this stem up and down. Second part, we have a diaphragm here, or disc here is a flexible part that can provide the surface that convert this pressure to the force on this stem. Okay, that provide the surface that the air pressure can be exerted on the stem, and is connected to the top of the valve stem. So it can move the stem up and down. And last part is the spring, which is here. So this spring provide a force against the air pressure. So because this spring will define for us at which air pressure this valve has to be open or closed. Okay, so by using this spring, this spring put a force against the air pressure here, and it can force us, it can define the pressure of the air that is needed to open or close this valve. Okay, and we can design this valve in a way that once we have, now in this case, once there is no air, pressurized air here, the valve is open. Once we put the pressure, the valve will be closed. But we can design it in other way, that when there is no pressure here, the valve will be open, and when we put pressure, when there is no pressure, the valve will be closed, not like this, and when there is pressure, the valve will be open, not exactly the inverse of this operation. So that all depends. We call it air to open, air to close. Okay, this valve now is air to close. Once we put pressurized air, the valve is closed. We can have air to open. When we put air, the valve will be open. Okay, hydraulically operated valve. So in hydraulically operated valve, instead of pressurized air, we have pressurized oil in those lines. Instead of pressurized air, we have pressurized oil. And most of the hydraulic valves are called ROV, or remote operated valves. ROV, or remote operated valves. So those valves are used usually remotely on the site. Okay, in the open area on the side, and they are used only for isolation, opening fully open or fully closed. Hydraulically operated valves, that we also call them ROV, they are used remotely on site and only for isolation. Those are some figures of hydraulically operated valve, that they work by using oil pressure, pressurized oil. This is another figure that you can see here. And okay, fine. Okay, now electrically operated valve, there are another type of the valves that, as I said, all the time, the main body of the valve, this part, it can be anything. It can be a gate valve, it can be even a ball valve, it can be a plug valve. But this part at the top, it can be pneumatical, it can be hydraulic force or electrical force. Electrical force, what does it mean? We can have a motor with some gear here, that once this motor moves, once this motor rotates, it can rotate this stem. Once this stem is rotating, it can goes up and down, it can open or close the valve. Okay, so this is kind of type of plug valve operated electrically with a motor. This is a gate valve operated electrically with a motor. And this valve, okay, this kind of electrically driven or motor driven valve, they are usually use when we have a big, very large valve. When we have a very large pipeline, a very large valve, and we need a big amount of energy and force to open or close the valve. So in that case, it's hard for operators or workers to do this by hand. So we will use kind of electrically operated valve, and with the motor, that once this motor works, comes to the action, the valve will be open or closed. Where is used? This application is important. In aircraft de-icing, agricultural application, and also in automated fire suppression devices. Okay, those are important. Agriculture, aircraft de-icing, and automated fire suppression. Okay, I'm gonna stop this video here. So until slide 48, and I will upload another video for slide 48 until the end of the unit. Hope you enjoyed this video, and please let me know if you have any question. Thank you.